Hi, here are your Lesson 7.3 video notes. In this lesson we hope to define for you what does 0 as an exponent mean and how to use it, and we hope to define and use negative exponents as well. On your notes template that you have a big table here, and we hope to use this big table to set up an easy pattern and to end up having you know what you already know about exponents to understand what does 0 power mean and what will negative powers mean. So to set up this easy pattern, we're going to use 2 just because it's an easy number to do powers within our head. So we'll always have a base of 2 down this column here. And the pattern we want to have is we want to have that be 2 to the third power, the one above it 2 to the second, the one above it 2 to the first, then 2 to the 0th power will be there in the middle. And then we can go back and we can actually have 2 to the negative 1, negative 2, and negative 3 power. And if we start off with this one down here at the bottom, that 2 to the 3 power, what does that actually mean? You were probably taught that that means that you have 3 2's all multiplied together. So 2 to the third power is actually equal to 8. And I think everybody knows 2 to the second power is 4. And that would mean we have 2 2's over here multiplied together. And 2 to the first power is 2, and that means that we have a 2. Now if we start looking at what pattern we have developed in this section right here, how do you go from this row to the row below it? Does it keep going? Well, it would be to multiply by 2 to multiply by 2. Well, if we go back up this column this way, what pattern is there? Because we should be able to use that pattern to come up with what will 2 to the 0th power mean. And to go from the 8 to 4, you just divided by 2. To go from 4 to 2, you divided by 2 again. So to go back up another row, if we start with 2 and we divide by 2 again, we'll see that 2 to the 0th power is 1. And it's not just 2 to the 0th power is 1. Any number a to the 0th power will always be equal to 1. So if you'd get that filled in your notes down there, we can go through and we can say that if you had an algebra a, any number you want it to be, to the 0th power, it will equal 1. If you go over here and have an example of this, we could have 5 to the 0th power, and we can write down 5 to the 0th power as 1. We can continue on, and this might be kind of tricky for you to think of because negative 5 to the 0th power will equal 1. And the tricky part of that is you might want to think, well, negative 5 to the 0th power is going to equal negative 1, but it's actually equal to positive 1. Anything to a 0th power will equal 1. And to develop your understanding of why that is, let's now take a look at this, what's called expanded form. Let's change your thinking, not that this means to multiply by 2 3 times for 2 to the third power, but that it actually means to multiply by 2 3 times. So you see it as times 2 times 2 times 2, and that's going to force us to say we need to put a number out there in front. Well, if we put a 0 out here, 0 times 2 times 2 times 2 would give us a 0 here. So it's not going to work to put 0 out there. I'm going to take that 0 out of there and that 0 out of there. What would work is to have a 1 here. And then 1 times 2 times 2 times 2 would equal 8 still. And if we have this as 2 to the second power, meaning that we are multiplying by 2 2 times, we'd have to put a 1 out there, and a 1 times 2 times 2. 2 to the first power means that we're going to multiply by 2 1 time. So we have a 1 out there in front, and that's 1 times 2. 2 to the 0th power is going to mean that we're going to multiply by 2 0 times, but what number would we still have out in front there? It would be to have a 1 there. And if we continue looking at the pattern that we looked at a minute ago, we can go back up here now and decide what should 2 to the negative 1 power be. Well, if this pattern continues, 1 divided by 2 is going to come out to a half. And if the pattern continues farther back, which it should, if we divide by 2 again, 1/2 divided by 2 is actually 1/4. And if you take a fourth and divide it by 2, you'll get an 1/8. And if you don't like doing that with fractions, if you want to grab a calculator and see what you get if you do 1 divided by 2, turns into 0.5, and 0.5 divided by 2 on a calculator is going to turn into uh, 0.25, and if you take the 1/4 and you divide it by 2 again here, you will get 0.125, and that's the same thing as an eighth. So if you're wondering and you want some clarity about why this is this, let's go back and let's make sure we're starting with 1 again, and think, if positive 1 means we're going to multiply by 2 one time, negative 1 should mean the opposite. What's the opposite of multiplying by 2? The opposite would be to divide by 2. So that's where this is going to come up with, if this actually means 1 divided by 2. And if you think back to fractions, if you're going to divide by 2, you are actually going to keep the first number and change this to multiplication, and the 2 gets flipped. And if you remember, what was the name of flipping the 2? It's to call it the reciprocal. So what we're really doing is we're keeping the 1, getting rid of dividing by 2, and we're going to change it into multiplying by a half. And if you think of it that way, you can see that 1 times a half equals a half. Well, if you go up to the one above it, we should be starting with 1, and we should be dividing by 2, but dividing by 2 is really the same thing as, instead of dividing, it's multiplying by the reciprocal of 2. So if you do 1 times a half times a half times a half, the 1 times 1 gets you 1, the 2 times 2 on the bottom gets you 4. That's where you can get that that's 1/4. And if we go to look at the 1/8, this would be 1, and if it's divide by 2, divide by 2, divide by 2 3 times, that's really to multiply by a half, multiply by a half, multiply by a half. And that will get you where you do 1 times 1 times 1 for the top, which is 1. The 2 times 2 times 2 for the bottom is 8, so you get 1/8. And probably the best way for you to think about this is to realize this 2 right here, if you make it its reciprocal, 2's reciprocal is a half, and now the 2 on the bottom gets raised to the 3rd power. And it's a positive 3 power for multiplying by a half 3 times. This 2, if you take its reciprocal, is a half, and if it's a negative 2 power here, once you make it its reciprocal, it's a positive 2 power there. And 1/2 to the 2nd power does equal the 1/4 that we have here. And to fill in this other one where we were writing things with positive exponents, if we have 2 to the negative 1 power, that will change into 1/2 to the positive 1 power also. So if we drop down to the box down here for our key concept area, if you have a to a negative power, it will be the reciprocal of a to a positive n power, which means that in writing this in algebra using a variable such as a to a negative nth power will equal 1/a to a positive nth power. If we come over here and write that with numbers, if we had 2 to a negative 1 power, it will be equal to 1/2 to a positive 1 power, which equals 2. We also could go backwards doing this, that if we had 1/2 to a negative power on bottom now, that we're really going to do the same thing again. We're going to use the reciprocal to get it back to being a positive power. That's equal to 2. So if we have 1/n to a negative 1 power, it's equal to a, that was an nth power, a to the positive nth power. Once again, this is the reciprocal, and I spelled reciprocal wrong there, it looks like. Alright, your rest of your notes template is examples, and for example 1, they want you to use the definition of zero negative exponents to simplify these. If we look at how to do a right now, 3 to the negative 2 power, we're going to change that so it's a positive power. Right now it's 3/1, and if we make that the reciprocal, it's going to become 1/3. So it's 1/3 to the 2nd power now, and now the power for it is positive. and that's going to equal 1 over 9 if we simplify it so that we have it changed to the simplest form. The next one, if we have anything to the 0th power here, the answer is going to be 1. So the answer to that one is 1. In the next one, we do have a negative power here again. It's raised to a negative 2 power, and we're looking at having the fraction 1/5 raised to that negative 2 power. So we really should change it to 1 over 5 to the 2nd power. Now it's a positive power because we have the reciprocal, which the 1 on bottom really doesn't matter because it's 1 times 1. The 5 on top becomes 25, so that's the answer to that one. If we look at 0 to the negative 5th power, we would want to make it so it's the reciprocal, that if this is over 1 right now, it's going to become 1 over 0 to the positive 5 power. And if you have this, 0 to the 5th power is 0, and that puts 1 over 0, and you have division by 0 there. This is actually undefined as an answer because you cannot divide by 0. For example 2, I'd like to encourage you, pause the video and work those out on your own. This is going to take a combination of what you've learned here along with what we have learned in lessons 7.1 and 7.2. So pause the video, try working them out on your own, then come back. Welcome back. To do A here, we have 6 to the negative 4th power times 6 to the positive 4th power. We should know we need to add those exponents if we're multiplying the same base together. The negative 4 and the positive 4 make 0, so 6 to the 0th power will equal 1. If we go to the next one, we are raising a power to a power. We should know we'll multiply. The base will stay 4. Negative 2 times positive 2 is negative 4. So after we get this, this is going to change so it has a positive power of being 1 over 4 to the positive 4th power. And now if we change that so that 4 to the 4th power, you need to grab a calculator to do that, but it's 256, so it's 1 over 256. In example C here, we have a 3 on the bottom that's to the negative 4th power. And if it's a negative on the bottom, it will need to get moved up to the top, and then it would change into being a positive power is the easiest way to think of that. So you'll have 3 to the 4th power, and if you want to, you can put it over 1 and think of it as being the reciprocal again. But 3 to the 4th power now is 81. May have needed to grab a calculator to do that one as well. And if we go to this, we have a negative 1 power on top here, and it's being raised to a positive 2 power on bottom. And since it's division, you should know what are we going to do with those exponents? It's to subtract. So we have a negative 1 minus 2. And for subtracting integers, if we turn it into adding the opposite, we really have negative 1 plus a negative 2. So this is going to come out to be 5 to a negative 3 power, which is 1 over 5 to a positive 3 power, which then becomes 1 over, and 5 times 5 times 5 is 125. So our answer to that is 1 over 125. And if we move forward again, example 3 just has a part A and part B to it, but there are more steps to doing this, and I'd encourage you again, pause the video and work them out on your own. Alright, welcome back to the video. To do this, the first one, the key thing to doing this would be to recognize in the parentheses how many bases do you have that should be getting raised to this 3rd power. The 2 is a base, the x is a base, and the y is also another base. So the 3 as an exponent should go to the 2. That would be 2 to the 3rd power, which is 8. The 3 should go to the x as a power, which will make it x to the 3rd power, and it should also go to the y, which is being raised to the negative 5th power, so we're going to have y to the negative 15th power. Now, directions say write your answer using only positive exponents. So we cannot leave this written as to a negative 15th power, so we need to change it. The positive powers, which would be 8 to a positive 1 power and x to a positive 3 power, will stay on top. the y to a negative power is going to move to the bottom and become a positive power. There's the simplified form of that expression. On part B, the first thing that I clue into or start looking at and paying attention to is that this is a negative power right there, and I would like to get that changed to a positive power. So if I start looking at what's on top and bottom, I want to keep the y to the fifth where it's at because it's a positive power. I'm going to keep the negative 4 on bottom. I'm going to keep the x squared on bottom. I'm going to keep the y squared on bottom. But this part that's raised to a negative 2 power, I'm going to move down to the bottom and have it become 2x to the positive 2 power now. And then as I go through other steps to simplify this, the y to the fifth stays on top. The negative 4x squared is still on the bottom. Y squared is still on the bottom. And I'm going to square the 2 and the x right now, and I'm going to get 4x squared. Now if I start looking for what can I combine, one of the first decisions that I'm going to want to make, will this answer be positive or negative? This negative sign means I have a negative times stuff on the bottom, and I'll have a negative number on the bottom. The top is going to be a positive number, so a positive divided by a negative, the whole answer is going to be negative. If I started with the top and started looking for if I can look at this y to the fifth, is there anything that will work to combine with it? Yeah, the fifth and the second, we should be subtracting those. This will become y to the third power. That takes care of those. Now if I look, I have a 4 here and I have a 4 here. That stuff on the bottom's all multiplied together. 4 times 4 is 16. And the last thing I have to look at is I have a base of x here to the second power, and I have a base of x here to the second power. Multiplying those together on the bottom, that's going to become x to the fourth power. And putting all that together, that's what you should have for your final answer there. If we go to example 4, it's just an example of standardized tests, giving you a little bit of a story problem, dealing again with order of magnitude. This is the mass of a polyphemus moth larva when it is hatched is 10 to the negative 3 grams. It's pretty small because 10 to the negative 3 is 0.001, so it's a very small part of a gram, and a gram actually is about what a small paperclip weighs. Reading on, it says during the first 56 days of its life, the moth can eat about 10 to the fifth times its own mass in food. Well, its own mass is that number. About how many grams of food can the moth larva eat during its first 56 days? Well, this was about 56 days. That's about 56 days. We don't have to do any math with the 56. We just have to take the mass of the larva, written in order of magnitude, and we have to multiply it by the fact that it eats 10.5 times as much. And if we multiply those together, we get 10 to the second power, because we added the negative 3 plus the 5. We look at our answers and we should recognize 10 to the second power is 100, which makes our answer C. That concludes your video notes.